So we're moving on to lesson 4 in the reactions unit. This has to do with mass stoichiometry. So let's define what mass stoichiometry means. First of all, a funny sounding word, stoichiometry. The word stoich is a Greek word. It means element, and metry is the English suffix that means to measure. So it means you're measuring elements. And more specifically, it's the math that surrounds working with a chemical equation that tells you if you put in a certain amount of reactants, you're going to come out with a certain amount of products. In terms of numbers, it actually allows you to compute the numbers, and that's what stoichiometry is. It's the math of using a chemical equation. Now what mass means is it means we're going to be working with the weight or the mass of a substance. That is the number of grams, specifically how many grams of that substance. So let's go ahead and talk about that. So we need to measure in grams, liters, and molarity, and then we need to convert to moles. So let's look at this chemical equation down below. So this is one we've seen. It's converting methane and oxygen into carbon dioxide and water. So what it's saying is that you need 2 molecules or 2 moles of oxygen, O2, for every 1 mole of CH4 that you put in. So it's counting numbers of particles. It says 2 oxygen, 1 CH4. 2 oxygen, 1 CH4. It's matching up particles and counting them. It doesn't understand weight. It doesn't understand volume, which is how much space something takes up. It doesn't understand those things. It just counts particles. Unfortunately, we can't see an atom or molecule or weigh it. It's too small. And when we take a mole, which was designed to give us a big enough bundle of atoms and molecules that we could actually see them and weigh them, we can't count them. And that's what the chemical equation needs. It needs us to count those particles. So a mole is just too big a number to count. So unfortunately, we have a problem on both ends. One end is too small, one end is too big. Fortunately, chemists came up with a way to tell how many actual molecules we have in a sample or how many moles we have in a sample by using weight. So down at the bottom is chemical world. That's what the chemical equation understands. It understands those numbers of particles. By the way, that little animal is called a mole. Moles were not named after that animal, but just so you remember it, that's a mole. That's what a mole looks like. So what do we measure in? Well, if we go up to the top there, we measure things in grams. So we have scales like that. They're called triple beam balances, or you could just use a conventional kitchen scale to weigh, but we can weigh things in grams. The 2 things that are required to do mass stoichiometry is you have to have a pure substance. So it has to be pure water or pure oxygen or pure nitrogen, because you have to have a substance where all of the molecules or atoms have the same molar mass, the same number of grams per mole. So it has to be a pure substance. Now it can either be a gas, liquid, or solid. We can use any of those states of matter for mass stoichiometry. Then you have to have a translator. We are able to measure things on a scale in grams. The chemical equation needs numbers of particles. It needs moles. So we need a translator that gets us from grams to moles and then gets us back out from moles back to grams when we have our final product and want to know how many grams we have. So we compute this using the molar mass. And there you see the equivalency for carbon. 1 mole of carbon equals 12.01 grams of carbon. Again, look at your periodic table. The 12.01 comes off of your periodic table. So it relates how many particles, 6.022 times 10 to the 23rd particles of carbon, atoms of carbon, equal 12.01 grams of carbon. So we can deal in grams. We can measure that on a scale. The chemical equation needs moles. So this translator, this molar mass conversion, which we call an equivalency in this case for carbon, helps us to translate between grams, between mass, and between number of moles. So that's the translator right there. And then that gets us from grams to moles and then back out to grams again when we're done. Okay, so now we're going to do 3 stoichiometry problems. Let me introduce you to this graphic organizer. So you see the chemical equation down below in the dashed blue line. And I call that chemical world because everything in there has to be done in moles. Those numbers down there, the 1 CH4, the 2O2, the 1 CO2, they don't understand grams. Grams mean nothing to it. We need to get it in terms of how many particles, how many atoms, how many molecules. And so everything inside that dashed blue line is in terms of moles. Now, up above at the top, we have grams. So we can measure things in grams. That's why you see the little children there. That's our world. That's something that we can measure in. And so we're going to put the number of grams there. And then to translate between the grams and the moles, or to go back from moles to grams later on, we need the molar mass. And that would be, for CH4, it's 1 mole equals 16.05. How do we get that? Well, carbon is 12.01, and 4 hydrogens are 1.01 times 4. That adds up to 16.05. For oxygen, an atom of oxygen is 16 grams, but an oxygen molecule, and oxygen always travels in molecules like that, not just in single atoms. So 2 times 16 is 32 grams for an O2 molecule. Carbon dioxide, again, carbon is 12.01. You get this off your periodic table. Oxygen is 2 times 16 is 32. You add 12.01 and 32, you get 44.01 grams for 1 mole of carbon dioxide. And for water, oxygen is 16, hydrogen is 1.01, you multiply that by 2, and you get a total of 18.02. Okay, so those are going to translate and get us in and out of the chemical equation. So here we have a problem up above. How many moles of CH4 are required to form 8 moles of H2O? So what we're going to do is put a question mark in the box that we're looking for. So you look in the moles row, and you look for CH4. And see if you can find that. Find the correct box. You're going to put a question mark there because that's what the question's asking for. How many moles? So there it is down there in the box that's has a red line around it now, red box. Okay, so that's moles. It's in the moles row, and it's CH4. Now we start with 8 moles of H2O. Where are we going to put that? Well, you stay in the moles row, and you go over to where you see H2O in the chemical equation, and that's where you put the 8 moles. Actually, there's the line first. There you go. There's the 8 moles. We don't have to write moles because it's in the moles row, so we know it's moles. So what you need to do in this problem is get from that 8 over to that question mark. Okay? So you need to know a relationship between moles of H2O and moles of CH4. Well, that's the purpose of the chemical equation. It tells us that there's 1 mole of CH4 will equal 2 moles of H2O. In other words, you take that statement straight out of the chemical equation. The only thing you have to add is the word moles to it. Here it's in the moles row, but when you write it in a chemical equation up above, you're going to need to add that word moles. So we're going to go ahead and do that. So we start off actually by putting down what are we starting with. So you put that way over on the left. You're building an equation now for this chemical reaction. 8 moles of H2O times something is going to equal some number of moles of CH4, and that's what we're trying to find out, the number of moles of CH4. So you need a relationship between those two, and the relationship is this. 1 mole of CH4 equals 2 moles of H2O. Again, look at the chemical equation. That comes exactly out of the chemical equation. 1 CH4, 2 H2O. You just add the word mole. The 1 mole CH4 equals 2 moles of H2O. Now, we are going to turn that into 2 conversion factors. You can either say there's 2 moles of H2O for every 1 mole of CH4, or it's equally true to say that there's 1 mole of CH4 for every 2 moles of H2O. Those are both true statements, but only one of them is going to help us to answer this question. So now we have to ask ourselves which one of those 2 goes in that box above. So think about it in terms of cancellation. What do you want to cancel out, and what do you want to appear on the top at the end? So think about that. Pause the video if you need to. Okay, so the answer is going to be that one. Why? Because it has moles of H2O on the bottom. That will cancel out with the 8 moles of H2O, just the moles of H2O. Okay, so there, cancels there, and cancels there. And the only thing we have left, I call it the last man standing, is moles of CH4, and that's what we want for our final answer. We're trying to find out the number of moles of CH4. So there's moles of CH4. So whatever is left uncancelled in your equation has to be in your final answer. That's what's going to end up in your final answer. So you want to be sure those 2 things match up. Moles of CH4, moles of CH4, and they do. Once you have your units of measure and substances lined up properly, you can now do the math. 8 times 1 divided by 2. And you see we're doing 8 times 1 divided by 2, and that gives us 4. So that's our answer, 4 moles of CH4. And we can go down in our box down at the bottom where the question mark is and put a 4 in there. So think about it, it makes sense. If 1 mole of CH4 is going to produce 2 moles of H2O, then 4 moles of CH4 is going to produce twice as many moles, 8, of H2O. And so that's how you do a simple one-step stoichiometry problem. Okay, now we're going to move on to a two-step stoichiometry problem. That means you need to make 2 conversions to get to the answer here. So let's read the question. How many moles of CH4 are required to form 3.2 grams of H2O? Okay, so we want to come out with some number of grams that we can measure on a scale. There you see a little scale appear there in the upper right of the graphic organizer. That's our world. That's what we can measure things in. Okay, so what do we need? We need to know how many moles of CH4. So let's start with the H2O this time. Where do you put the 3.2? It's in the grams row. That's our world, what we can measure in, and it's where H2O is. It's above H2O. So it's going to be right here. 3.2 grams of H2O. That's what we're trying to end up with. Now we want to know how many moles of CH4 it takes to do that. Where are you going to put the question mark? That's your question mark, what you're trying to find. It's again down in the moles row and above CH4. So there it is. There's the question mark. So how do we get from 3.2 to question mark? You can't go diagonally. You have to go up and down or sideways. Okay, so here we go. We're going to go first down through the molar mass to convert the grams of water into moles of water. So now that puts us in the box down below there, where in the moles row. Once we have the moles of H2O, we can do pretty much what we did on the last problem. And we're going to go across from moles of H2O and find out moles of CH4, and that's what the question is asking us for. How many moles will it take? Okay? So you see up above the equation formed, you have the 3.2 grams of H2O over on the beginning, because that's what you know. Now, even though the chemical equation is going from left to right, it's going from CH4 to H2O, the math equation is going from what we know, 3.2 grams of H2O, on the left over to what we don't know over on the right, which is the moles of CH4. So notice the math equation is going in the opposite direction of the chemical equation. That doesn't matter. Just keep in mind how you write a math equation. You start on the left with what you know, you end up on the right with what you don't know. Okay, so here we go. So now it's going to take 2 conversions. Why? Because there's 2 different sets of arrows. Those down arrows are really the same arrow. So 3.2 down into the equation and then across. So our first equivalency is going to be what? Well, it's going to be the molar mass. 1 mole of H2O equals 18.02 grams of H2O. And from that we can create 2 conversion factors. There's 18.02 grams of H2O for every 1 mole of H2O, or it's true to say that there's 1 mole of H2O for every 18.02 grams of H2O. Those are both true statements. Okay, now think about it. You have grams of H2O at the beginning of this problem. It doesn't appear in the final answer, so it has to cancel out. So which of those 2 conversion factors are you going to put in the box to make grams of H2O cancel out? Think about it. Pause the video and think about it if you need to. Okay, I'm going to go ahead and show you. It's that one. So we're going to go ahead and put that one up here. So why is that? It's because 3.2 grams of H2O is up on the top. Remember, if there's only one level, it's on the top, the numerator. And then you have 18.02 grams of H2O down on the bottom. Now, all we're doing now is canceling units of measure. We're not canceling numbers at this point. So we're going to go ahead and cancel grams of H2O and grams of H2O. They cancel out. And so what you have right now on top there is moles of H2O. Now, if you did this calculation, and you don't do this calculation normally in a problem, but I'm just showing you how this problem works, you would end up with 0.18 moles. You see in the box down on the bottom right, 0.18 moles. That's what you would have at this point. We don't care about 0.18 moles. That's not what the question asked us for. So we're going to go ahead, and now we're going to do the second conversion, and that's to get from 2 moles of H2O over to some number of over to 1 mole rather of CH4. And this is exactly what we did in the last problem. So this is the same thing. 1 mole of CH4 equals 2 moles of H2O. You have 2 moles of H2O over 1 mole of CH4, or you flip it. 1 mole of CH4 over 2 moles of H2O. Okay, so which one of those two is going to go in the box? So think about this. You have moles of H2O in your first conversion. That doesn't appear in your final answer. So you need to make that cancel. And you have moles of CH4 in your final answer over there on the right. And that does appear, so you need that on the top. So which one are you going to use? You're going to use that one. So we put 1 mole CH4 over 2 moles of H2O. Moles of H2O cancels there and there. And the only unit left, the last man standing, is moles of CH4. Okay, so now, because the units match up, the last unit remaining in our equation is the same as the unit we're looking for, moles of CH4, it means we're ready to do the math. So 3.2, you multiply everything on top and divide by everything on the bottom. So 3.2 times 1 times 1 divided by 18.02 divided by 2. And when you do all of that, you end up with 0.094 moles of CH4. And if you want to, you can go ahead and write it down where you see the question mark down in the graphic organizer. There is 0.094 moles of CH4. So that's a two-step problem. Alright, now we're going to move on to a three-step problem. This is a grams to grams problem. You're going to start with some number of grams. You have to end up with some number of grams. So how many grams of H2O can be formed from 5.2 grams of CH4? Okay, so think about where the question mark is going to go, grams of H2O, and where the known value is going to go, that's 5.2 grams of CH4. So the 5.2 grams of CH4 goes up in the grams row, our world, and it's up above CH4. For the H2O, where's the question mark go? Grams of H2O, it goes over there on the right. The question mark goes in the grams row and above H2O. So the question is, can you just go straight across from 5 grams to question mark and get your answer? That would be a one-step problem if you can do that. The answer is no. We don't know a relationship between grams of H2O and grams of CH4. And this is a key concept in stoichiometry. The only relationships we know are down there in the chemical equation. That there's 1 mole of CH4 for every 2 moles of O2, 2 moles of H2O. The only relationships we know are in moles. So what does that mean we have to do? It means we have to take the 5.2 grams of CH4 and we have to convert it, use the molar mass of CH4 to convert it into moles of CH4. And that'll put us down in that box inside the chemical equation. Now we have to go across. The only place you can go sideways, left and right, is inside the chemical equation because it's the only place we know a relationship between the substances. So we're going to go across from moles of CH4 to moles of H2O. Then once we have moles of H2O in that box in the bottom right, we're going to come back up through the molar mass of water. 1 mole of water equals 18.02 grams of water. And we're going to get to our question mark, and that will be our final answer. So that's a three-step problem. We're going to need 3 conversions to get from grams of CH4 to grams of H2O. Okay, so here we go. So I'm writing a little smaller because this is going to be a long equation. So way over on the left is what we know. It's what we start with in the math equation, 5.2 grams of CH4. Way over on the right is grams of H2O. That's what we're trying to get to. Okay, so you see 3 different arrows, the down arrow, the across arrow, and the up arrow. And so that's going to be 3 conversions. So there they are, 3 boxes for conversions. So now we're going to start with the first one. We need to get from grams of CH4 to moles of CH4 using the molar mass. So our equivalency is 1 mole of CH4 equals 16.05 grams of CH4. Okay, that gives us 2 conversion factors. 16.05 grams of CH4 over 1 mole of CH4, or 1 mole of CH4 over 16.05 grams of CH4. Which one goes in the box? Well, we're starting off with 5.2 grams of CH4, and grams of CH4 is not going to appear in our final answer. So we need to make that cancel out. So the one that's going to make that cancel out is the one with grams of CH4 on the bottom. So it's going to be this one. So we put it up there. Grams of CH4 cancels with grams of CH4. So now what we have is 5.2 times 1 divided by 16.5, and since the only units you see there that haven't been canceled are moles of CH4, that will tell us how many moles of CH4 we have. And you can go ahead and you can put that down in the box there for CH4. It's 0.29 moles. Now we don't care about that number. You won't normally do this calculation in the middle of the problem, but I'm just showing you how this is flowing. Okay, next we need to get from moles of CH4 over to moles of H2O, and we've done this in all three of the last two problems. 1 mole of CH4 equals 2 moles of H2O, so be sure you understand that relationship. It comes straight out of the chemical equation. So there it is, 1 mole of CH4 equals 2 moles of H2O. You create your two conversion factors. You just put one over the other and then flip it. Okay, so now which of those two is going to need to go in that box? Well, you see in your first conversion you have moles of CH4 on the top, and moles of CH4 does not appear in your final answer, so you need that to cancel out. So which of those two conversion factors are going to make moles of CH4 cancel out? Think about it. And it's going to be this one. So if you put it there, you have moles of CH4 on the top. It cancels with moles of CH4 on the bottom. Remember, you can cancel across a times sign. Alright, that leaves us with moles of H2O. So over on the bottom right of the screen, you see moles of H2O, and that's going to give you, if you did this calculation, again, you will not do this calculation, this intermediate calculation, you get 0.58 moles of H2O. Now we're ready for our final conversion to get us out of the chemical equation and back to our world of grams and our final answer, because we're trying to find out grams of H2O. So what's our conversion? What's our equivalency for that? It's our molar mass conversion for water. 1 mole of H2O equals 18.02 grams of H2O. Now you simply put one over the other to create a conversion factor, and then you flip it to create the other conversion factor. Okay, so which of those two are going to go in that box up above? Well, moles of H2O isn't in the final answer, so we need that to cancel out. And grams of H2O is in the final answer. It's over there on the right, so we need that to appear on the top. So the one we're going to use is this one. So we put this one up here. So moles of H2O cancels with moles of H2O. The last man standing, the units that didn't cancel out, are grams of H2O, and that's what we want in our final answer. So that's how we know we set the problem up correctly. Okay, is that what we have as our final unit that didn't cancel out in the equation is the unit we have for our final answer. So now we're ready to do the math. You multiply everything on top and divide by everything on bottom. So 5.2, way over there on the left, times 1, times 2, times 18.02, divided by 16.05, divided by 1, divided by 1. And what you do then is you just crunch all those numbers and you come up with the number 2.9 grams of H2O. And if you want, you can put that down in the graphic organizer where the question mark is. And there it is. That's your final answer. So this is going to take some practice, but if you're willing to practice this, you will get good at it. You don't have to be a genius. You just have to practice the steps, and it will come through to you. All right, so that takes care of our lesson on mass stoichiometry.